Welcome back. Today, we're going to be talking about the greatest common factor and we're going to be going over some word problems. So, the greatest common factor is the largest number that evenly divides two or more numbers without a remainder. For simple examples, we can just list all the factors of each number and choose the greatest on the list. And for more complex examples, we're going to be using a factor tree on both numbers and seeing which prime factors are common amongst both, and then multiply those common factors specifically together to find the greatest common factor. So let's dive in. Maria has 36 candies, and her friend Alex has 48 candies. They want to create gift bags with the same number of candies in each bag, ensuring that all candies are used and no candies are left over. What is the greatest number of candies they can put in each bag? Okay, so this is a greatest common factor question because whatever number it is has to be a factor of 36 and a factor of 48 simultaneously because they want to make sure there are no candies left over after they do, and they also want every bag to have the same number of candies. So that's how we know it's a greatest common factor question. For this one, I'm going to be using the listing method, and then for the next one, I'll use the factor tree method. But for the listing method, I'm just going to list all the factors of the various numbers. So let's start with 36. For 36, we know that 1 and 36 are factors of 36 because 1 times 36 is 36. Now, what about 2? This is even, so 2 will work. Therefore, it's going to be 2 and 18. Now, also 3 and 12 would work as well, because 3 times 12 is 36. And the last one is 4 times 9 is 36 as well. So I'll just kind of sneak 4 and 9 in there. And then the very last factor here that isn't part of a factor pair would be 6, because 6 times 6 itself would make 36. All right, let's do 48. For 48, we have 1 and 48, so I'll start there. What about 2? We have 2 and 24. 3 would also work, so 3 and let's see, 16. And then 4 would also work as well, 4 and 12. And then 5 is a no. 6 would be a yes, because 2 and 3 are both on the list. 6 times 8 is 48. And 7 is a no. So those are my lists. So the largest number that appears on both lists simultaneously is 12. And so therefore 12 is the answer to this question and the greatest common factor. The greatest number of candies they can put into each bag is going to be 12 candies. All right, but yeah, if there's any questions for that one, feel free to leave those in the comment section. Let's move on to the second example. A librarian has 80 mystery novels and 100 science fiction novels. She wants to arrange them in identical stacks with the same number of books in each stack and no books left over. What is the greatest number of books she can have in each stack? All right, so for this one, I'm going to be using the prime factorization, the factor tree method. So let's start with finding the prime factorization for 80. So 2 times 40 is 80. So I'm going to write 2 and 40 up there. 2 times 20 would be 40. 2 times 10 is 20. Then we'll go this way. 2 times 5 is 10. So therefore 80 is equal to 2 times 2 times 2 times 2 times 5. Or you can write 2 to the power 4 times 5. Then for 100, 2 times 50 is 100. 2 times 25 is 50. And 5 times 5 is 25. So 100 is equal to 2 times 2 times 5 times 5. So to find the greatest common factor for this one, we need to circle or highlight everything that appears on both lists. So I noticed that a 2 appears on both lists, a second 2 appears on both lists. Now a third 2 and a fourth 2 only appear on the first list, not the second one, so I'm not going to highlight either of those. And then there's there's one 5 that does appear on both lists. The second 5 on the 100 I'm not going to highlight because it's not something in common with 80. And so the answer is 2 times 2 times 5, which is 4 times 5, which is 20. So therefore, the GCF is 20. And therefore, 20 is the greatest number of books that she can have in each stack. As always, if you have any questions, feel free to leave those in the comment section, and we'll see you for the next one.